Chapter 11 is going to talk about conic sections. So we are going to go a little bit away from what functions are, because we know that functions pass the vertical line test. So if I had a function, we know that this is not going to be a function because it fails the vertical line test. So we're going to look at different types of conic sections. So that sometimes are not going to be these functions that we've been dealing with. And in particular, we're going to be dealing with a circle, parabola, which we've done before, but it will be in a geometric sense, an ellipse, and also a hyperbola. So these are the four different conic sections that we're going to talk about. And basically these occur by basically taking some, I cannot draw, but let's say this is a cone, two different double napped cone, and you're basically slicing this cone with a plane. And what you get is that for every plane that you slice with this cone, you're going to get a cross section. So you might get a circle, you might get a parabola, you might get different types of figures. So these are the four that you're mainly going to look at. But before we go to the conic sections, we do have to emphasize two different things. And one of them is what we call the distance formula. So we're going to talk about distance and midpoint in this particular video. So what exactly is distance? So let's say we have 2 points in space. Here's my x and y axis. Here's my first point. Let's call this x1, y1. Let's call this x2, y2. Oops. And what we want to figure out is how far is the distance between this point to this point. So this is x1, here's x2, here's y1, and here's y2. Okay, so we want to find this distance, d. So one of the things that we can use is the Pythagorean theorem. And the Pythagorean theorem basically says that if you have some sort of rectangle, we can figure out the longest side of the rectangle using a squared plus b squared equals c squared. Now, how does this look like a triangle? I don't know if I said rectangle, it's a triangle. So we can find the sides of this triangle using this particular formula. How am I going to get a triangle from here? Well, I can always just draw a triangle like this. Here is a 90-degree triangle. And all we just need to figure out is what A and B is. Well, we know what C is. That's just going to be our D. But first, what is going to be this side? Well, this side is the length between x1 and x2. So in order for me to find the length or this distance, all I got to do is just take x2 and subtract it by x1. And notice that they're squared. Now for my b, I just have to take this distance and this distance. This is going to be my b. So this distance is just basically this y2 minus this y1. Whole quantity squared. And now the c is just d. This is just d. So now my d, all I got to do is just take the square root. D equals the square root of x2 minus x1 whole quantity squared plus y2 minus y1 whole quantity squared. This is the distance formula. Notice that I didn't put plus or minus in this problem because since we're looking for distance is positive, it wouldn't make sense for us to have a minus there. So let's do a couple problems using the distance formula. So here's my example. So find the distance, okay, between the points. And here is going to be my first one. So part A is going to be the distance between -4, -5 and 5, 7. So the first thing that we want to do is plug it into the formula. So we know that the formula is D is equal to the square root of x2 minus x1 whole quantity squared plus y2 minus y1 whole quantity squared. Now, what's going to be x2 and y1 and y2 and y2, whatever? So you can label them however you want. I can say this is x1, y1, x2, y2. You can flip them if you want. You'll still get exactly the same answer. As long as the first one is the x1, as long as the first one is the x and the other one's the y. So let's just plug everything in there. So it's going to be the square root. x2 is going to be 5. Minus x1, which is going to give me -4, whole quantity squared, plus y2 is going to be 7 minus -5 whole quantity squared. So this is going to be the square root. This is going to give me 9 squared, and this is going to give me 12 squared. So what I end up getting is 81 plus 144. And this is just going to be the square root of 225. And when I take the square root of 225, that's going to give me 15. So basically, these 2 points are 15 units away. Okay, that's basically all it is. So not too bad. Let's do another problem. Let's do part B, and let's say we want to find the distance between 1, 3 and 2, 7. And what I want here is I want both exact and approximate. I want both the exact and the approximate answer. So let's start off. Let's just use our formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. And now the first thing that we want to do is label all of our points. I'm going to label this x1, y1. It's going to be x2, y2. I'm going to plug everything in there. So I have the square root of x2 in this case is going to be 2 minus 1 squared. Y2 is going to be 7 minus 3 squared. So this is going to give me the square root of 1 squared plus 4 squared. It's going to be the square root of 1 plus 16. It's going to give me the square root of 17. This is what we're going to call the exact answer. And it's exact because here all we have is just no decimals. Exact just means I don't want anything else. I just want the decimals. That's all I really want. Now, the approximate answer is going to be the decimal. So plugging that into your calculator. Now, if you have the TI-36, and if you put square root of 17, you might not end up getting the decimal answers. So what you want to do is when you get your TI-36, right when you press enter, so the enter, which is going to be the last button all the way at the bottom, on the bottom right above it, you're going to see kind of like this sign, like 2 different arrows. Press that button. This button is going to give me the approximate answer, and you'll see what it is. So when you press square root of 17, you might get square root of 17. Press the button right above the enter sign, and what you're going to get is about 4.12. The approximation of that is going to be 4.12. Okay, so just be very aware of approximate versus exact answer. Okay, so that's the distance formula. That's basically all it is. Nothing too terrible. Now, the last thing that I want to talk about in terms of formulas is now the midpoint formula. So the midpoint of 2 different points. So let's say I have the point x1, y1, and then I have another point x2, y2. And instead of finding the distance here, I just want to figure out the midpoint, the middle point. This thing is what we're going to call the midpoint. Now, this is very self-explanatory if you kind of think about it, because the midpoint is basically going to be the average of the x values and the y values. So the midpoint is going to be x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So I'm basically taking the average of the points and dividing it by 2. That's basically all I'm doing. So all I got to do is just plug them in, label x1, y1, and all those other fun stuff, and then just find the midpoints. So let's just do two quick examples. So let's find the midpoint. Okay, so let's do it for the first problem. The first problem is going to be -3, -5, and 5, 7. So let's find the midpoint of these points. So the first thing that you want to do is let's label x1, y1. So here's going to be x1, y1. It's going to be x2, y2. So my midpoint, based on the formula, is going to be x2 Oops, well, I wrote x1 first. So x1 plus x2 doesn't really matter. And then y1 plus y2 over 2. So let's just plug everything in. So it's going to be 5 plus negative 3 divided by 2. And then y1 is going to be negative 5 plus 7 over 2. Notice it doesn't really matter if I flip them or not. These two should actually be flipped. But notice that it'll still give you the same answer. So what is this going to give us? So 5 minus 3 is going to give us 2. So this is 2 over 2. And then this is going to give us another 2. 2 over 2. So my answer here is going to be 1, 1. That's going to be my final answer. Okay. So now let's try another problem. One last one. So let's say we want to find the midpoint between the points negative 2, negative 5, and 6, negative 1. It should be a positive 6. Okay, so let's find the midpoint. Let's use a different color. So midpoint is going to be x1 plus x2 divided by 2, y1 plus y2 divided by 2. So let's just label our coordinates, and let's plug them into the formula. So x1 is going to be negative 2 plus 6 divided by 2. y1 is going to be negative 5 plus negative 1 divided by 2. Okay, and now what we're going to get, well, 6 minus 2 is going to give me 4 over 2. This is going to give me negative 6 over 2. So I'm going to get 2, negative 3. So this is going to be my midpoint. And that's all there is for midpoints and distances.